Me oh my, have we got some fresh imagery for you tonight here at the Smash News Network, least busted name in news. I'm your host, Dan, a.k.a. Smash-O-Mash. These are all 24-hour videos, all of our Helio Viewer movies. They're 24-hour videos at 30 frames per second. There's no more interesting star to look at than the closest one. And again, like I said, we've got some stunning imagery for you, to say the least. So we'll get back to that here momentarily. There's a 48-hour video real quick, as we've had a rather exciting sunspot group set over there in the west. Pardon my partial transparency. Maybe can I become more solid? There we go. That's better. Yeah, so we do have a very high likelihood of X-class solar flares and yet another coronal mass ejection on the way. One just struck an hour ago and all kinds of things going on. So if you enjoy the content, don't forget to press the like button. If you're new to the channel, press subscribe. Otherwise, how would you expect to receive the world's most comprehensive daily space weather content and most detailed solar imagery in the known universe, delivered directly to your YouTube subscription feed? SNN, the Smash News Network, least busted name in news. Opinions expressed in this video are not necessarily the opinions of Smash News Network. All right. And so first of all, volcanoes. Shiveluch is an inhospitable place. The entire Kamchatka Peninsula, frankly, is inhospitable, as heavy snows and strong winds occur there. Not sure if Shiveluch is erupting or not, is my point. Mount Ibu, also exploding. 10,000-foot ash plume over Indonesia from Mount Ibu. Also Semeru, Ruang, Popocatépetl, Fuego, Poas. Somebody's car alarm is going off. Sangay in Ecuador exploding. 23,000-foot ash plume there over Sangay. Also Revenador, Sabancaya, 26,000-foot ash plume. And Poyahu Cordon Cale is probably not going to erupt. It looks like there's some magma motions from leftover magma from the 2011 eruption. As far as quakes go, earthquakes have been calm for the past 24 hours. Only one 5 or greater magnitude event. That one occurred on the West Pacific Rim near Vanuatu at 13:33 Universal Time today. That's April 29th. You may be wondering if coronal holes can be used to forecast earthquakes, and the answer is not. Not only do they not cause earthquakes, they don't forecast earthquakes either. Just like the channels that claim coronal holes forecast earthquakes. Earthquakes happen without coronal holes, and coronal holes happen without earthquakes, folks. Now, before we get to some more stats, let's take a look at some more insane imagery. Oh, it's bonkers. It's bonkers. That's our SGO magnetogram plus 171 angstroms. And we'll get back to that and check it out. You can see some limb darkening happening over there on the western limb. That is another earthly directed coronal mass ejection. So some of that will miss to the west. Some of it will strike Earth. It's coming almost directly from center of solar disk, originating right here in this area below my mouse pointer, right in the right there it goes. So yeah, that's another Earth-directed CME. We'll get to it. But first, some more stats. So yeah, the radio flux is now at 140, I think it is. 140 is the radio flux. So there it is, plotted for the past year by that black line. The F107. Space Weather Enthusiast Dashboard forecasting geomagnetic unrest the night of May 1st into May 2nd. So, multiple CME impacts coming. 2 more on the way after the one that's just struck a few hours ago. And you can see NOAA there showing a little bit of activity there, both at Stereo A and at Earth. Around the same time there, late night on May 1st into early morning on the 2nd. ESA also agrees, and so does our channel. If you watched our video yesterday, you would already know this. Next, we'll look at Earth's magnetic moment from space as modeled by our space weather modeling framework. It's our Geospace Magnetosphere movie. It endeavors to show us what the magnetohydrodynamic pressure around planet Earth should look like. I suspect they may be using the ACE as the active spacecraft right now, but yeah, things are looking a little more calm on there than they may be in reality here. So same thing with the ground magnetic perturbations map that we're showing you now. That's Earth's magnetic moment from the ground, and that may not be accurate either. I don't think either of those are accurate. It's been looking bad for the ACE lately, folks. The ACE has been looking bad in terms of showing odd numbers on the solar wind data. So there could be something going on with the ACE. Let's hope not. KP index is all right. It is only at KP 1.33, so that is pretty geomagnetically calm. So there's what the ACE is picking up, and look at how low the solar wind density is. That doesn't look right. I mean, 1/4 of a proton per cubic centimeter? I don't think so. Solar wind speed there elevated. It is showing the CME impact. So right in here, right around 1744 universal time, a minor CME impact hit once again as the channel forecasted. And there it is on the Discover with more believable readings here. So that space weather modeling framework needs to switch over to the active spacecraft Discover. Yeah, that's a believable solar wind there. Just under 10 protons per cubic centimeter for the solar wind density, solar wind velocity here. Coming back down to 425 kilometers per second. But you can see that different magnetic regime and a rapid shift in both the solar wind density and the speed. Also the plasma temperature, which is that bottom green line. And there are our magnetometers located at about 23,500 miles of altitude in their geosynchronous near equatorial orbits. The GOES 16 and GOES 18 magnetometers. They're measuring the magnetic field of Earth way out in the outer portion of the outer Van Allen belts. Next, the heliosphere magnetism, and Earth is snapping into a North Pole magnetic sector. So there is a current sheet afoot. As that magnetic sector switches, there's going to be a current sheet at the sector boundary crossings. And so current sheet showing up as we make the video. And if you're wondering what that's going to feel like from Earth level, the answer is it's not going to feel like anything because it's not going to be measurable unless you're out in space. It does interact with Earth's magnetic field, but it's not going to interact with you directly. You are well within a much stronger magnetic field, so you don't feel that interaction. You can't measure that interaction from the ground. So anyway, yeah, North Pole magnetic sector probably already here or showing up within the next hour or two. Facts. And the time of day right now, by the way, folks, is 4:48 p.m. Eastern Time. 4:48 p.m. Eastern Time. This video was recorded, not streamed live. There are the past 4 days of the solar magnetic fields, the B field, the polar fields, and the photosphere magnetism, where you see the sunspot magnetism. That's the photosphere. The B field is the blue lines. And then the red and green potential field surface source lines, those are north and south polar fields. Green for north, red for south. Coronal holes is next. We've got both north and south pole-oriented coronal holes here on the solar disk. And I would be expecting to see Oh, no, that's right. Yeah, snap into the North Pole magnetic sector here. So, as you would expect, seeing North Pole-oriented coronal holes here rotating in from the east. So that's no surprise at all. And let's take a look at SDO's imagery. So these are South Pole-oriented coronal holes. And then over here, these are North Pole-oriented coronal holes. And no, they do not mean earthquakes are coming. I mean, people can keep repeating over and over again nonsensical things. That does not make nonsensical things true, folks. That is what a cult does. So just, it's bonkers. Sunspot number is currently at about 108. 108 sunspots right now. Let's take a look at them from SDO. Actually, let's look at our flare probability monitor and scoreboard first. There we are. And we agree that sunspot 3654 is very likely to produce an X-class solar flare, and we're about to show you why. It's because magnetic shear, and it is violent magnetic shear right now going on. So here is there's the thing. Welcome to the Smash News Network, least busted name in news, where we show you the things at the place because the dude downloaded the stuff. Yeah, we got the gear. We got the gear, folks. So that's another 24-hour video, 30 frames per second. And here we've rotated the field of view to keep the sunspot essentially stationary from your perspective. And, well, we're about to show you where the likelihood of X-class solar flares is highest. All right, so here's our magnetogram. And right here in the middle, you see some cleavage happening right there. Yeah, some magnetic cleavage. And that right there is the area of massive magnetic shear. So there are some other spots, but if you look at that right there, you can see there are opposite polarity sunspots very close to each other. So that is the point of, shall we say, most resistance. Two very strong and opposing magnetic fields right in the center of a large sunspot group. So that is what you want to see if you're looking for large flares, and we are. As that sunspot gets closer and closer to the limb, the likelihood of an X-class solar flare increases by like 5%. All other things remaining the same, which they're of course not, but just the location itself is part of the probability. And we think that has to do with perspective, folks. We think that has to do with the fact that a solar flare may be anisotropic, meaning if you measure it from one angle, the same solar flare may show higher intensity at different viewing angles, as many things in astrophysics do this. For example, stars, galactic cores, etc. In other words, perspective is super important. And here we've put the 94 angstroms wavelength along with the HMI magnetogram. I told you we had some stunning imagery tonight. Have I let you down in the past? Of course not. And there's a sunspot just by itself. We've allowed the field to move normally now. There is at least one M-class flare. I think just one M-class flare in there, I think. It's been pretty quiet, but don't expect that to continue because, well, proximity to the limb and a sunspot that's not degrading. That's what you want to see. Good times. Oh, we've also got 131 angstroms, I guess, while we're here. There you go. Not half bad. And that's some fine work by Smash staff, by the way, for sharing the content on social media and so forth. Let's blast through our coronal mass ejections sections. Oh, we've got to do energetic particles and flares. Geez, we are behind schedule. So as far as energetic particles, we ain't got none. The ghost proton flux is flatline. There it is. X-ray flux, yeah, only one M-class flare in the past 24 hours. Solar system forecast is next. That's where things will be in 1 week. We're approaching the new moon early in the month of May. Next, what's going on over our head? SkyandTelescope.org claims that's what's happening. Mercury and Venus are being chased to the horizon by the closest star. And here's our astronomy photo of the day. It features Uranus, Jupiter, Comet Pons-Brooks, and the crescent moon. Very nice. It probably took 2 images to get that, actually. The sky, that's probably a second exposure there to get this like that, and that's fine work there. That's fine work there, Juan Carlos Casado. Fantastic. So, CMEs are next. They're kind of important. And we've got a bunch of missing data, so that'll speed up this section. Although this one is good. So, according to George Mason University, I think it's early in the morning, actually. Let's see here. All right, let me press refresh. Yep, well, there's an event that comes out of the west. I don't know what else to say. These data are, look, ancient. Stereo A's data is ancient, ending at 9:38 this morning. So we're just going to look at our custom coronagraphs and say Fui, not to be confused with Hong Kong Fui on that. All right, so toward the end of this video, you're going to see some limb darkening right in here. That will have an earthly directed component, and that will arrive sometime on the 2nd. So around sometime like midday around the 2nd, as early as midday and as late in the day on May 2nd. So another CME impact. So that makes 3. They'll all be minor. 3 minor CMEs on the way. So it's this filament eruption right there. Right in that area. It's to the east of that sunspot while it is on its way out. There's a closer view. It happened at like 1200 Universal Time. Maybe 1100, something like that. And these videos come from helioviewer.org. By the way, if you want to make your own, we encourage you to do so because there just isn't enough good coverage of space weather. There's a lot of crap coverage of space weather, but there's not a lot of good coverage. I mean, Tamitha Skov, definitely thumbs up Tamitha Skov. Right, next filaments, and we've got some, quite a few. Some are huge. That one down in the southeast is worthy of a name. That's Big Bear's ground-based hydrogen alpha telescope. And look at that thing down in look at that right there. Dag, that is a burly filament, right? Let's hope that one blasts off and tries to end civilization. If mankind, of course, doesn't find a way to do it himself. So, yeah, of course, just kidding, folks. That filament will not end civilization. All right, so here are the past couple of hours from the GOES A16 SUVI. Again, very high likelihood of X-class solar flares out of that sunspot 3654. 3654 is an exciting sunspot. Bonus features are next. Satellite charging hazards are non-existent. The GOES electron flux here is in a moderate operating range. There's the 1-year graph to contextualize the electron flux. There is the forecast model. NOAA is expecting flat levels of electron flux, but we'll see dips when CME impacts show up. The harder they are, the bigger the dip. Next, the layer where it's measured, the F-layer. There it is in vibrational frequency. The F-layer is at about 300 kilometers of altitude. It is the bridge between Earth and space. It's the space side of the bridge between Earth and space. The Earth side of the bridge between Earth and space is the D layer. But they're both the ionosphere, so the argument could be made that they're space because it's above the neutral atmosphere of planet Earth. It's mostly ionized, which makes it kind of like space. There's the anomalygram, anomaly in megahertz from the 30-day median. So yeah, we are seeing some anomalies here, a lot of low-frequency ones, and it's because CME impacts have been showing up. So this is going to be contrary to some of the data that you see, like the geospace magnetosphere movies and the ACE, which is showing some really weak solar wind. Well, it's not always right. You got to understand what you're looking at, and I don't know what else to say. That's just how it works. Understand what you're looking at, or you ain't looking at jack. You're saying ooh and ah about things you don't understand. Next, the total electron content. That's literally the free electrons between ground level and your GPS satellite. So GPS satellites are at like 12,500 miles of altitude. The TEC is the free electrons between you and your GPS satellite. They cause signal refraction and hence GPS errors. If you have no Wi-Fi hotspots and you're navigating with GPS, you can get errors, and that is going to show you when the errors could happen. You might not make a wrong turn on your next group ride. Maybe you'll make a wrong turn on purpose. You got to mix it up out there. It gets boring. Next, the latest. There we go. There are some things, and it looks like a new sunspot rising over there. What do you got? You got an umbra? It ain't got no umbra. Not yet, at least. And let's move on to weather. Weather, Earth's weather. There is the world's stormiest sea area. 39-foot waves right there. Over 40 footers down there in the Southern Ocean. Right next to the French, Southern, and Antarctic lands. And by the way, there is actually a beach right there. Look at that. It's the Plage des Lions Mains. The Plage des Lions Mains. So yeah, there's some big wave surfing that you could do right there, right at the end of that glacier. So yeah, that sounds like a delight, right? Yeah, it's autumn down there. Why not go surfing? Look at that. There must be massive waves. Of course, there is an onshore wind. You know, you want to have an offshore wind. But that's the world's stormiest seas. That's surface winds and significant wave height. Some pretty stormy ones down here as well, south of the Pacific Ocean. Anyway, here's meteorology, regularly scheduled. Surface winds of the east and your jet streams. Jet streams of the central world. Surface winds. The Americas. And the jet streams. Again, that island is the French, Southern, and Antarctic islands. Probably not what you'd consider a hot surf spot. But right now, there are probably some big waves breaking. And there might be some penguins or something. I don't know. Puffins? Something. Some kind of Antarctic something. Anyway, here's our satellite imagery. We've got a low chill in there in the North Atlantic, making its way up toward Greenland, it looks like. And here's our windy.com map, and we're showing snow depth. Check it out. There's still quite a lot of snow. Flagstaff has snow right now. Alpine, Arizona has snow. Large portions of New Mexico have snow at the moment. And there's more to come to some spots. Here's our weather.gov map to show you the warnings. And of course, I'll briefly show you the key there. That's where your warnings lie, and here are your forecasts, GFS 72-hour pressure and precipitation, as some severe weather has made its way out into the Gulf, thank goodness. Some lingering late-season snow coming to large portions of the U.S., so that's noteworthy. There is our 72-hour GFS accumulated positive snow depth change forecast in inches. And a big chunk of the country there is going to get some significant snows. As much as almost a foot in some spots there. And let's check our snow extent and mass balance and so on. So the mass balance is just right around the standard deviation there. Kind of right in the median. Right in the average. Right in the center of the average for plus or minus 1 standard deviation for the snow mass balance. Snow extent is at +1 standard deviation above normal for this time of year. And the snow water equivalent is well above the +1 standard deviation. That's for 1998 through 2011. Of course, it's a case of fire and ice across the U.S. as it's very, very hot in Pennsylvania, like 90 degrees right now. So that's our temperature anomaly forecast in degrees Celsius for the next 72 hours. And it's going to stay pretty hot and pretty fast for all of you cyclists out there who are riding the Lehigh Valley. Cheers. And for you real weather nerds, there's the jet stream forecast. Real weather nerds, pilots, pilots are real weather nerds after all. And yeah, that's your jet stream forecast. The 250 millibar winds, courtesy of tropicaltidbits.com. Very nice. Next, lightning. And look at the intense lightning that made its way out of Louisiana and into the Gulf. Again, like I said, thank goodness that storm has exited, probably leaving a swath of damage and destruction behind it. Things like damaging wind and hail were certainly likely. We still do have lightning striking here off the coast of Galveston. Probably some water spouts. Look at that. Dag. Well, and now, of course, it's probably a good time to surf the Gulf Coast. I'll bet somebody's got a wetsuit on at Freeport. Quintana Beach. That sounds like a delight. Named for Colombian cycling superstar Nairo Quintana. Who knew? Who even knew that? Definitely nobody, because I definitely just made it up. All right, so here's our U.S. Doppler radar map. A long string of storms from Canada all the way to the Gulf. We showed you the full 50 states. We showed you the weather from the photosphere all the way down to the lower 48. Fire and ice, baby. The U.S. has got it. And dear God, that's better. And we are closing this thing out. So take the opportunity to type a comment and press the share button. That's your visible satellite for the lower 48. Some violent weather has left the country and is moving into international waters or something. Thank goodness. Go away, deadly storms. Here's your recap. Vertical motion of water droplets in the air column. That's what Doppler radar does. Visible satellite from the NASA GOES Interactive Weather Satellite Suite. Very nice. And let's take a brief moment to zoom way in on that behemoth. That is some violent weather right there. Look at the rapid cloud nucleation happening. Hot water and pressure gradients coming together, folks. And there is our water vapor map. And here's me closing out. Thanks for tuning in. May that solar wind be at your back. I've been your host, Dan, a.k.a. Smash-A-Mash. And until next time, may that solar wind be at your back.